Welcome back to the Rad Lab Podcast. I'm Dr. David Dan, and this is a continuation of our interview series. And today we have a special guest all the way from NASA. He is the principal investigator for space nuclear propulsion at NASA. He got his PhD at MIT in nuclear engineering. He spent time at Los Alamos National Lab. He has won numerous awards from NASA. I don't need to name them all, but he's won quite a few. And he is an associate fellow of the American Institute of Aeronautics and Astronautics. And his name is Dr. Michael Houts. Thank you for being here.
Oh, my pleasure. Thank you for having me.
Yeah, it's been, when I saw you on the docket for our seminar list, I was like, this is one of the people I would definitely want to get on. Space is just, everyone loves space, right? You can't, there's hardly anyone who doesn't like space, right? Yeah. So to have someone sitting across from me from NASA and doing something like space nuclear propulsion, which we'll get into a little bit, and we'll have to see how much you can get in with it, but hopefully you can give us at least the basics. But before we do any of that, I like to start, from the beginning.
Okay.
Right? I like to start from the beginning. So where are you from?
Okay, so I was born in Massachusetts, and then lived in Iowa for a while, and then down in Florida, and then went back up to Massachusetts for grad school, and then got to work out in New Mexico at Los Alamos National Lab. I was there for a total of 11 years, and then kind of oscillated back and forth between New Mexico and Alabama a couple times, and then ended up now I'm down in Madison, Alabama, working for NASA Marshall Space Flight Center.
Awesome. So were you always interested in science, or was it something that you learned to love?
So, I as far as I can remember, it was more, just interest growing up, and a lot of that was like my parents. My dad would take me out. We lived in Massachusetts, and I remember once we got stuck in a blizzard. Which, when you're 3 or 4 years old, that's a whole lot of fun. When you're the parent trying to drive the car, I'm sure it's not as much fun. But anyway, by the time we got home, we looked out, and there's a totally clear sky, and there's a comet there over like a couple feet of fresh snow, which was why we'd been stuck in the and it was. So really started getting interested in space and nature, and then that, of course, led to science. And then don't remember when I first got interested in nuclear engineering. It was in grade school, and then after got through school, got to college. I was an undergraduate, and had a professor tell. I was still very interested in space. Growing up in Florida, of course, went to as many launches as I could, and really liked the space program. And just had a professor tell me, well, if we really want to move out into space, we're going to need nuclear power. And so that's when I went ahead and went into nuclear engineering. So really since my high honors project, and then through grad school, and work at Los Alamos, work at NASA, I've been really blessed, gotten to work on space nuclear power and propulsion systems. And so I still think they're going to be really important as we move out into space.
Wow, that's amazing. So you were interested in space from an early age. It was space first, and then came everything
it was
else.
kind of stargazing, and then watching rocket launches, and so very fascinated in space. And then, okay, how do you really do something big in space? And that's why I started getting interested in space nuclear power and propulsion. And so there's all kinds of really fun careers related to the space program. So I shouldn't, but just for me, that's what got me going the direction I'm going.
Yeah. How did you make the switch to nuclear? Because it's something that not everyone gets exposed to until later in their careers. And for me, it was more of it was kind of, for me, it was like the frontier of it, the frontier of chemistry in my mind, and, working with stuff that people really don't get the chance to work with. What was your...
Yes, I can't remember if it was a TV show or if it was talking to somebody. I think my first thing, or the most recent thing I remember, was in 5th grade, we were talked to sketch out some kind of invention or something, and mine was a nuclear powered automobile. But as far as what made me think about that, because I remember at the time I was like, well, that's a no-brainer. I'm going to do my nuclear-powered automobile. But I actually don't remember what the exact moment was when I thought, well, hey, nuclear engineering's a good thing to do. I do know it's it's a really good source of energy. I mean, if you look at just the energy density compared to chemical reactions, it's got tens of millions of times the energy density. So a very small amount of uranium can provide it's almost indescribable amounts of energy. You take like a 2 train cars full of just standard reactor fuel, that'll power a nuclear power plant for 18 months. if I try to do that chemically, just as an example, you get I think it's 100 train car loads of coal per day, to power a coal plant, versus 2 train car loads, over 18 months. So, just little things like that, and then I know there's a lot of, I guess you'd say. I want to say it's not. I don't want to say fear of the unknown, but it's just that's one of the things about things associated with nuclear power that sometimes people get nervous about. But I really think once have a good just a good open public education campaigns, which we're having a lot of recently, I think that'll really help allay those concerns. Because even if if you and I are convinced, hey, this is the absolute best source of energy, you don't want people being stressed over it. You don't want people being nervous about it. So you really want to have a very good, open, frank discussion. But I think just the last few years we've seen really a tremendous upswing in support for nuclear energy just because of its attributes. It's it obviously doesn't emit CO2. It's a very clean form of energy. It's very safe. We're on our 4th generation of reactors now. We know how to scale them. We know how to build them. There's a lot of companies starting up building them. So, but as far as when it first clicked, I was. Again, can't remember the exact moment that it really clicked that nuclear engineering was a potential thing to think about.
Yeah, and like to piggyback on a lot of that, the job market is wide open.
Oh yeah,
it's getting bigger and bigger. I think the big push to nuclear is we just can't, with the push for electric cars and all these things that people want. We need power to power all these things.
Oh yeah, you need electricity.
And coal and things are just not going to cut it, or just are so dirty compared to nuclear that it only makes sense that we're moving in this direction now.
Yeah.
Right.
Oh yeah. I think there's even universities. I want to say University of Illinois. I know is seriously considering putting almost maybe one of these small modular reactors that there's a lot of talk about on. I think they're considering putting one of those on campus. I think that's a great idea. I mean, as far as training students, really could have a very positive global impact with systems like that. So you're right. Things are definitely seem to be moving that direction.
Yeah, and if you're listening, TTU is starting a nuclear engineering program.
Yeah.
So if any of the things we talk about today are interesting, I would say look into it. We'll put a link in the description towards TTU, and you can look into and see if it's a path you want to go down. Because I think right now, the market's going to be so open. Unfortunately, the people in the field are getting older and older, and we don't have enough people to replace them. So, if you're worried about job security, this is one of those things that can really keep you going for a long time. Yeah. And
coming in from the outside, I've had a great tour today. Looking forward to the seminar, but just to me, this is just a great potential location for something like one of those small modular reactors, or to have a nuclear engineering department, something where you're training the workforce and training them on the kind of the most modern systems, the current modern systems that are really applicable, not just in the U.S., but really around the world. They're the right size. They're very advanced from a safety standpoint. They're very reliable. So it's so again, I think to me, just look at this campus, and of course I'm sitting in here in this beautiful chemistry building, with what is it, like 3 years old? So
yeah.
State of the art equipment. So it's easy to get biased that way. But to me, it'd be a great opportunity.
Yeah, and the new engineering building just right across the street that they're currently building too. So there's so much opportunity here, and I think the one thing that the university has done a lot of is put a lot of money into the sciences and engineering and things, and we always love to see that, right?
Yeah.
So so much opportunity here, and if you want to get on the ground floor, because it is turning into a ground floor, because we're kind of almost starting over with all the people retiring and things like that. It's that's one of my biggest worries, is some of that knowledge loss might happen because of the overturn that we're going to see in the next decade or so.
Yeah.
So we need people to come in and be able to take up those positions for sure. So talking about school and talking about, possibly going to grad school and things like that, how was your graduate school experience at MIT?
So it was really good, but I will say it was because I was able to work on something I was really interested in. So I was able to did a couple summers out at Los Alamos National Lab as an intern, and then also worked down at the it's now the Air Force Research Lab. It was the Phillips Lab, I think, at the time I was down there, but it was had a couple summers down there. But I was always getting to work on space nuclear power and propulsion systems, and so I would say. Just advice is, especially, undergrad, it's good to get a real solid foundation. But then once you have that really solid foundation, then find something you're really interested in. Because if you're really interested in something, it just makes grad school really fun. It makes your job really fun. And so that's a huge advantage to me of a college education, is it gives people the opportunity to just work on something they're really interested in. And it's great to, it's great to work. We need to work, to support ourselves, but boy, if you can do that in combination with doing something that you really like, it's just something getting better than that. And of course, I'm all for grad school. Like, I got to tell one quick story. My favorite related story is a guy, and it was long before he'd gone to grad school. He I think he did end up getting his PhD, but he. When he was about 18 years old, he was a smoke jumper. And these are the guys that they jump out of an airplane, parachute out of an airplane maybe 500 feet above basically an out-of-control forest fire. And this was a long time ago, so I'm not sure basically they have a shovel and maybe a few other things, and their job is to, make a fire break, and then they hike out when they're done and stuff. And I just remember him saying, he said it was one of the best jobs he'd ever had. And whenever he'd jump out of the plane, he'd say, I can't believe they're paying me to do this. Okay, so that probably wouldn't be for me, and I don't know what other people are, but I was just like, hey, that's a great attitude. So anyway, what's great about grad school is try to find a job. Yeah, obviously we got to make money, but try to find a job. Every now and then you're like, man, I can't believe I'm getting paid to do this.
Yeah. No, I think that's great, just great advice in general for if you're thinking about grad school. What makes it so much easier and so much more palatable is if you're really doing something that you enjoy and that you like.
Yeah.
Because I think some of the pitfalls that people fall into when grad school is they kind of just see it as the next step.
Right.
And they don't see it as like, oh, it's the chance to keep doing what I love or keep doing something that I like.
And set themselves up for a career that they love, and you got to take advantage of that.
Mm-hmm. And they also, when choosing their graduate program, they're maybe more worried about the prestige of the institution and not necessarily for the person they're working for and the work they're going to be doing, right? So, all things to think about. But yes, if you enjoy what you're doing, that's what got me through it. I don't think if I didn't enjoy what I was doing, I don't think I would have made it out.
Yeah.
And you see that happen a lot, just the nature of the beast, right?
Yeah.
So with grad school in mind, if you had to go back and do it all over again, but you could only take one skill with you, what would that one skill be?
I would say just be as communicative as possible. And what I mean by that is, just ask people what they're up to, what they're interested in, what their specialty is. And because it's amazing how many things interrelate. I mean, just the visit today, you guys have great students, great staff, just been able to, just really brainstorm up some pretty neat areas of kind of mutual interest. And so I'd say if someone, if they go to grad school, try to do that same thing, just because in doing that, they'll be more likely, say they go in and a few months in, they're like, I'm not sure. There are actually other things I'd rather be doing at 2 a.m. than, whatever. If they've been talking to people, brainstorming what all's out there, there's a really good chance that they'll say, but I think I'm really interested in doing this instead. So, it gives you a chance to, in grad school, really focus in on what exactly you want to do. And then just in general, like once you're working and you have a product that you're wanting to deliver, the best product possible, then it's great. You have, good networking, good connections, and you also kind of know what all's available. And it's amazing how many times talk to one person and boy, that'd be great, but it's impossible, and here's why. And they're good people, nothing against them, but then you'll go talk to a different person and they're like, that's fantastic. And such and such just made this one, breakthrough or this one observation that now we can finally do it. So don't necessarily take no for an answer if you're running into situations like that also.
Yeah, definitely communicate. And speaking about on to, talking and asking questions and figuring out and helping you figure out what you enjoy. I actually initially went to grad school for organic chemistry.
Okay.
And then talking with, I made friends and things like that. And, I had 2 friends that were working with, isotopes and americium in California. And they were telling me all the stuff they're doing. And, I was like, man, I really like that. I really don't like running 10 columns every day. So I think I'm going to switch over there. And that's when I ended up ultimately making the switch. And I kind of found, radiochemistry and nuclear science kind of late, later than some people. And it made the whole whole world of difference. And it's just, making those connections, talking, asking questions, all those things. Yeah, no, I think that's great advice.
Yeah.
So when did so you were working on space nuclear propulsion in grad school as well?
Yeah. So it's power systems, kind of a lot of propulsion systems, like high honors project in undergrad, and then my dissertation was related to power systems, and then did a lot of power system work at Los Alamos, and then a little bit of propulsion work, and then doing kind of a little bit of both at NASA now. So,
yeah. So for the people that don't know what the current propulsion systems are that are out there in space right now, could you describe them briefly and then kind of explain how nuclear propulsion works differently?
Okay, so right now it's we have some solar electric propulsion, and that's where you're using solar, basically solar panels to generate electricity, and then you run say an ion thruster or a Hall thruster using that electricity. And so those are very efficient. They'll have a lot of good uses, and then there's other types of thrusters that can be run off of that. But when we really think about propulsion systems, it's usually chemical engines, and so for example, liquid hydrogen, liquid oxygen engines. That was the space shuttle main engines. Of course, SpaceX is using a lot of liquid oxygen methane engines. And then we have solid rocket boosters. So for example, both the space shuttle and the SLS have solids, and the SLS, of course, is also using some of the same engines that were on the space shuttles. And so it's all chemical based. And then with solar electric propulsion, it's kind of a low thrust, even though it's high efficiency. So those are. So what we're really trying to do with nuclear is to get a really high efficiency, but also have a very if needed, a high thrust engine or like a high efficiency lower thrust engine. So the electric propulsion systems are usually lower thrust, but you can go to very high efficiency. And so that's one area of space nuclear propulsion would be using nuclear electric propulsion. A lot of different companies working that, and that'd be really for applications where the power levels are just too high for solar, or you're going too far out in the solar system, where you need to get the specific mass way down. Some of the advanced systems, there's a ex-astronaut doing a great job working on a thruster. He's wanting to do human Mars missions, and I think he wants to go on like 210-day round trip mission.
Oh, wow.
So that's so he's got his own thruster idea. He's been working on that. His idea really since grad school, and so that would be things like that would be fantastic. Then the one what we talked about today, it's a nuclear thermal propulsion. And so nuclear thermal propulsion, you really just take a propellant and you use the nuclear fuel to heat that propellant. And so one of the things nuclear thermal propulsion and nuclear electric, but just the comments focused on nuclear thermal right now would be you remove the energy density constraint. And so that's, again, like we were talking about how much more energy you have in uranium, than a chemical reactor. Fissioning uranium, tens of millions of times more energy than burning, chemically reacting an atom. So you really don't have an energy density constraint. And then you can use any propellant you want. You don't have to rely on, like we use hydrogen and oxygen. It's a very good propellant because it ends up with a pretty low molecular weight, but also as a chemical reaction goes, also has a very good energy density. So that's kind of your best chemical engine. But with nuclear, you use anything you want to for propellant, and you don't have that energy density constraint. So you have, that's kind of the carrot. That's why you say, okay, this is why we think there's some potential here. But then you get into the engineering and the details, and there's a lot of really important engineering that needs to be done. A lot of details to really take advantage of that. So the first systems we're going to be trying to do are just a solid fuel system. So you take a solid uranium-bearing fuel to make the reactor out of, and it'll run. Get pretty good efficiency. You get maybe twice the efficiency of your best chemical engines, and still at a high thrust. So that's a really good start. And then we're going to try to do a demonstration flight in 2027. And so there's a partnership between NASA and DARPA, and the idea is to fly a nuclear thermal propulsion system. I think the exact language is as soon as 2027. So again, we're trying hard. Team's doing a fantastic job pushing stuff forward, working really closely with industry on that, and so. But again, but the idea is just that'll be the first nuclear thermal propulsion system anyone in the world's ever launched, and then what we learned from that launch and the operation and just that whole process, the design teams, everything that goes into that. Then we would start applying that towards what we'd call operational systems, and then those operational systems, the idea would be to make sure that they give a significant benefit for use in, I guess, what we'd call cislunar space, which is really anywhere, from the Earth. I think they're defining it as just past the moon. And then based on the experience we get there, then start looking at, could we enable a quick, quick quote unquote round trip human Mars mission? So I mentioned the astronaut that's looking at. Former astronaut that's hoping to do, I want to say it's 210, 220 day round trip. With a nuclear thermal propulsion system, you'd actually be longer because he's using a very lightweight, very efficient approach that he's attempting to develop. And both of these still need a lot of work.
Yeah.
But with nuclear thermal propulsion, one of the goals is to try to get to where we could do, say, a 400-day round trip. And that would be a more advanced engine than these first-generation engines. But the idea is, again, that some people kick around is they'll say, well, we just had an astronaut come back after, I think it was 371 days on the space station. So that's a long time, know. And so, but the idea is, if you could do a human Mars mission in roughly that same amount of time, then maybe we'd actually go ahead and, try one. So the more advanced systems based on fission, we're hoping to try to get a round trip human Mars mission in under 400 days. And what that would, that gets kind of back into the range. We had the astronaut just came back from the space station after 371 days, doing well. And so the idea would be if we could get a human round trip Mars mission, shorter, then again that might make such a mission more viable. But there are architectures out there where we might spend 1,000, 1,100 days away from Earth and there's lots of very brave astronauts that are willing to do that. So, but this would be the kind of niche for a nuclear propulsion system. When you get to the second generation, really try to get to where you could do these fast round trip missions, be it either nuclear thermal propulsion or nuclear electric propulsion.
That's awesome thinking about going to Mars and making these round trips, and it's kind of crazy to think that we're at this point where we're thinking about round trips to Mars, and it's kind of amazing. But so. Just a couple questions about the nuclear propulsion. So you mentioned using it to power an electric kind of motor system.
Generate electricity, then use that electricity.
Yeah.
You could do ion Hall, MPD. There's the concept I mentioned is called Vasimir. Franklin Chang Diaz was the former astronaut that's been developing that. He's got a great lab down in Houston if you're ever down that direction.
Yeah.
But,
And that's mostly for while you're in space.
Right. Yeah, exactly. It's all in space use.
Yeah. And so, but the thermal propulsion, nuclear propulsion, that's for getting into space as well as in space.
Right.
Right.
Oh no, the nuclear thermal would actually only be in space.
Okay,
also.
so they're both just for purely in space.
And that's what's been so great about these companies that are really giving us affordable access to space is now you can that's helping a lot too. But it's because getting just mass to orbit. It really comes down to just the cost, you wouldn't be able to compete from a cost standpoint with some of the systems that are being developed now, which is fantastic news. But once you get in space, if you want to do something very ambitious, then that's where you really, cost is always going to be important, but you really need to also have the really high performance.
Gotcha. So when you're saying the thermal, so you have your solid fuel source,
right?
And you're using the heat from the thermal nuclear fission to then break the.
Yeah, just think of it as like a heat exchanger.
Okay.
So it's almost like if you took a heat exchanger, I'll just pick a number. Say you were running 2,500 degrees Kelvin, so it's pretty hot, but you just had this block. Or it could be particles that you're flowing a gas over, or it could be a block that you're flowing gas through. But just something. But you could keep that block at whatever temperature you wanted. Okay, so that would be, and you could blow as much propellant over it as you wanted to. That's almost the idea. So it's like a heat exchanger. So in this case, you have the, say you were using a block and you were using so you'd have the uranium inside that block, and it would just be fissioning at the rate needed to keep the block at a certain temperature. And then the propellant, it would be coming out of a propellant tank, and it would be being heated by that block. So that's a really, oversimplified way of looking at it. But it's really just from that standpoint, it sounds, well, that's just simple. It's just a heat exchanger.
Yeah.
It's like a radiator on a car or something. It's just a heat exchanger that you're blowing the gas over and you're heating the gas up. And that's, from that standpoint, that's true. It's simpler. But the complicated part is it's a reactor. And then, of course, as you can imagine, it's you always want to get that last little bit of performance or get things working a little bit better. So you want to run that block or the particles or whatever approach you're using, you want to run that as hot as you can. And so then you start running into materials limits. And talking to a lot of the chemistry guys today, you can kind of the materials and the chemistry is really very closely related. So it's so fundamentally it's very simple, but it's complicated because and you have to run you're running a reactor. You want to sustain the chain reaction, which is, and again, it's straightforward, good engineering. The good news is we've been doing reactors for 80 years now. So so it's so we're getting good at those, but it's always going to be a materials challenge. And then of course in space you want to make things very light, so trying to make things lightweight. But conceptually, and then with nuclear electric propulsion, it's a lot more analogous to a terrestrial power plant where you just use the reactor to heat a working fluid, and then you do some type of power conversion cycle and
turbine
and just recirculate it, and so there's some differences. We don't have a good heat sink in space, which sounds kind of funny, but if you think about it, you have excess heat when you're making electricity. And on Earth, the heat goes into the ocean or a river or any terrestrial power plant would do that. In space, it's almost like you're trying to get rid of the waste. It's like you're trying to reject heat into a vacuum thermos. It's so that gives you a lot of incentive to run at a higher temperature that you're getting rid of your excess heat. But then that higher temperature propagates back to your system. So now you want your fuels to run at a higher temperature. You want all your materials to run at a higher temperature. So it again becomes kind of a materials and chemistry problem also.
That's amazing to think about. Are you training your astronauts on like how to run a nuclear reactor?
Not yet.
Okay.
When we get to that point, that would be that's part of using the modern techniques, keep them very how to phrase it, just very user friendly. Again, the astronauts, we won't be able to have, like, say we were doing a human Mars mission, you wouldn't necessarily have a dedicated nuclear engineer doing the human Mars mission because it's going to be so hard. You're going to have to, these astronauts are going to have to be really, really good at like 10,000 different things. And so what we want to make sure is that the reactor is as easy to use, self-controlling, self-diagnosing, very reliable. Basically try really, really hard not to make the reactor a big time sink because the astronauts are going to have so many other things to be thinking about and worrying about. So, so right now there's not really a plan for it. Now, if you did have a nuclear propelled, human mission, then that definitely would be part of the astronaut training. Would be how to, how to run the reactor, what needed to be done. But on the flip side, you'd want to make it as benign as possible. I'll go back and pick on the space shuttle main engines. I mean, those engines were fantastic, and the astronauts knew a lot about those engines. But what was really great though is that they didn't have to. They didn't have to intervene, or there wasn't. It wasn't things that they were. The engines were just really, really well designed, really well engineered.
Yeah. So. How much weight are you projecting to save with a nuclear propulsion system over a conventional?
So it depends on the savings would be it's compared to conventional it'd be. Again, depends on the assumptions, depends on some people will say you'd save like a factor of 2, but I think the key might be now that, and it's great news, technology changes, the constraints change, we're getting really affordable access to Earth orbit. And so the idea would be if you had very affordable access to Earth orbit and you assembled a vehicle in Earth orbit, say for a human Mars mission, you might be more interested in on the performance. So rather than just I needed less of these launches that have now become very affordable. They're still expensive, don't get me wrong, but affordable compared to what they used to be. It might be that, so then the key is we really want to try to do a fast round-trip mission. And so it could end up being that the payoff for nuclear, for say a human Mars mission would be a really fast round-trip mission. And then the payoff for cislunar operations, it would have to show that, say we had, say a tug that was just taking lots of payload out, geosynchronous or out into other, beyond geo or, very cislunar destinations. Then that could be where you also get a cost savings. If you could make that tug very efficient and use propellant depots.
Like space gas stations, kind
of.
Yeah.
That's propellant depots. Yeah. And so a lot of it. And when we talk about things bootstrapping, a lot of it is the more infrastructure we have, the more we're getting out into space, then the more we're going to be able to really use these high performance systems. You might remember there were those studies around the, like 1900 or so, when there was no, there's no real infrastructure for automobiles yet in the U.S. Maybe 1895 or somewhere in that range, and that was one of the arguments that was made against the automobile was that they'd never beat a horse because a horse could refuel itself, but the automobiles you'd need something like 1,000 gas stations to be able to access the whole U.S. with cars. And of course, now I think last I heard there's something like 2 million places you can buy gas. So, but at that time it was like 1,000 gas stations. That's insane. I'm keeping the horse. And so we're kind of what I mean by that is as infrastructure increases, then higher technology options like nuclear that enable more things. Because obviously you can get from here to Los Angeles faster in a car than you can a horse, and an airplane beats them both. So but you need the infrastructure. If you didn't have an airport in California, well. People, the airplane's not going to be quite as good. So you got to have the infrastructure there.
That's a great point. I guess I hadn't really thought about that. As the infrastructure gets better and better, like the more options.
Then you have these options, and
Absolutely.
then the higher performance ones, and certainly with things like propellant depots and other things in space.
And assembling it in space and things like that.
Exactly. If assembling in space becomes easier, then that makes other aspects of things like human Mars missions easier.
It's amazing. It's getting me excited.
It is. The last few years have been really exciting, and it seems like it's getting better.
It's moving so fast. It's moving so fast. To think that we'd have people, just regular people, going to space on and maybe you could talk about the controversy about like who's an astronaut and who's considered that we have, I guess, space tourists, right? So what is the distinction now? I know NASA came up with a distinction for people who run space missions and then people who are like space tourists.
So I've kind of stayed out of that. I think either one would be really, really fun. So that's the level of depth I get into. But I know the space tourists, they think it's a fantastic experience. And then of course the astronauts, that's a different level. I'm just glad to see as many people as possible doing it.
Getting the chance. Absolutely. So, we have tons of students here and possibly students that are interested in possibly working for NASA. So what are some of the ways or pathways some of these students can take to end up at NASA?
So I think, again, the most important thing is find something you're really interested in and pursue that, because you want to be really good at what you're doing. And then, but then that said, look on the NASA websites, the various commercial sites, because a lot of the obviously there's a lot of commercial rocket companies now. There's a lot of they're talking now. I want to say there's several companies that are talking about private space stations, because there's been basically products or things developed on the International Space Station that they think they can commercialize, they can privatize. So that's going to be huge. So just broaden out a little bit to think just space in general. And so if you're looking at something. So if you're really excited about space, then just look, obviously look at NASA, but look, everywhere across the board. Okay, what are people really doing? Because there will be private companies doing really, really good work in space, and then find something that is really interesting, and then going back to we were talking about communicating and being open. Well, call the company and be persistent. And I will say, like, if someone calls once and they're really excited and you have a great conversation. From their standpoint, like say it's a student that calls and is really excited, and from the student's perspective, a lot of times they're like, well, I've already talked to this guy. But even if they thought it was a great conversation too, well, well, call back. I guess that's all I'm trying to say. Don't be bashful about calling the same person every month. Just let them know that you're still interested, because again, you could be a perfect match, but you got to keep talking to that people. So I guess the bottom line would be find something you're really interested in. Look at what NASA might be doing. Look at all the other space companies too. And once you start narrowing in, call somebody. Now they literally might say, oh well, I'm not working on it anymore, but I know this person, and they're working on it now. So just keep pursuing it until you get the good contacts there. And then once you have that, then NASA offers internships, of course. So just go to the NASA website, look under internships, but try to a lot of people, if you can imagine, a lot of people apply for those internships. So try to find the person that's working in the area you're interested in. Call them up, ask them if they're offering any internships. A lot of times people might not be offering internships, but they're be like, hey, that's a great idea. So I guess I just go back to find something you're really interested in, and then just communicate and be persistent and just track down the people that are also interested. And then that's probably the best way to get into any job. And then since you were interested in it, if it all works out and you'll just have a lot of fun going to work, and it'll be the same thing. Man, can't believe they're paying me to do this, So
yeah, no, it'll stick. Yeah, don't be afraid to be persistent. Like I think that's a lot.
Yeah, be very persistent, and because it's not bugging people. I mean, don't necessarily call them 4 times a day, but if you call them,
once a month,
that's great. Keeps you on the front of their, top of their mind.
And the forefront of their thoughts, and and everyone likes to talk about what they're doing. People,
exactly.
So
and they'll be happy to know that you're still interested. Because that's the other thing. They'll be sometimes if you don't hear from someone for 6 months, you're like, man, I hope they're still interested. You haven't heard from them. So
no, I think that's great advice. Yeah, like I think
get to conferences too. I should mention. I know a lot of conferences. Just look around AIAA conferences. We were talking nuclear earlier. You go to American Nuclear Society conferences. There's a Nuclear and Emerging Technologies for Space. That's a conference that mixes nuclear and space. I think it's like Santa Fe next year. It's like late April, early May, and it's going to be might be at Huntsville the following year. Not sure yet. So look for conferences. Look for conferences that are in your area of interest, and then most conferences will give like some kind of a student registration rate, and just try to get yourself to the conference. And again, but just don't get there and lean up against the wall watching all the other people talking to each other. Get in there, and it's kind of hard before you know anybody. But once you know a few people, then it gets easier and easier and easier. So try to get to events, I guess, where you'll also be able to meet people that have the same interests you have.
Absolutely, and usually they have some kind of job fair thing for
students.
Definitely
do job fairs and
So there's obviously there's a lot of options, and especially now, like when I was growing up, it was just NASA. Like that's if you wanted to talk about space or work in space, it was NASA. Right, but now there's so many options. SpaceX, I guess Amazon is.
They're starting to do something.
They're starting to do stuff too. So there's so many pathways now that I'm almost jealous that maybe I'll pivot here in the next 10 years or so. I don't know, but I think it's amazing, like the opportunity now for space. It's incredible, and maybe in the defense side, Space Force, that's also an option. So there's so many different ways for people to get into that space, I guess.
Exactly. So, and then just find the area that's of most interest to you and pursue that. It might be with NASA, it might be with all these other groups. So
absolutely. I think that's great. Well, I guess my final question that I got from someone else that knew I was going to talk to you today, and their question is, what is the biggest danger Space Force will have to contend with in the near future? This is one of their burning questions they had.
Okay. So, yes, I hadn't really thought about that. Really not acquainted with Space Force, but I've heard a lot of discussion, and they've probably heard the same things. And so the one that kind of stuck, one of the opinions I heard was that, we should really just be thinking of Space Force almost like the Coast Guard. So Space Force will be just keeping space open to everyone, and helping where they can. And so it's not really it's just that's just kind of an analogy I heard. But I guess I should have done it. I'd say just see what Space Force has out on their websites, and you can get to conferences. A lot of conferences now. A lot of the AIAA conferences will have speakers from Space Force, and you kind of get a better feel. But that's just one of the analogies that I heard. Just think of and the Coast Guard is extremely important.
Yeah, I think that's a great. I think that's a great analogy of comparing them to the Coast Guard. I think that's really good. I guess my last question, because we do have to get you out of here. We do have to get you towards this talk. Sure. So space junk. How worried are we about the amount of clutter that's in space.
Yeah, so I think there's we're starting to get more worried, and there's a lot of different ways and proposals out there for dealing with it. So it's something, it's how to phrase it. I think to me it's going to be the same as a lot of other problems. It's like starts out, things are happening and it's not a problem, and then things start happening at a bigger and bigger and bigger scale, and then people are like, well, maybe that's starting to be a problem, and then so I think, and then once everybody's like, yeah, that's getting to be a problem, then the problem gets solved. And so I think there's a lot of different ways we can deal with space junk, orbital debris, and so I think we are getting to the point because there's so many satellites now, and especially I think like you said, obviously we have just like Starlink, and I think is it Amazon that's starting up? I can't remember.
Yeah, they also started their own kind of Starlink thing
and
recently.
So, but that's fantastic because now people have internet access from everywhere in the world. And so it's going to be great. But there's just more satellites in general. So I think there's going to be interest in solving the problem. And there's just a lot of different ways to solve it. And so that's just something we'll need to focus on. And so I think it's to the point where people are recognizing, hey, that could be an issue. And so usually when something gets to that point, then someone comes along and says, I can solve the issue. I was going to make a joke for only $9.99. I can solve it. But free enterprise will work, and someone's going to come along and they'll have a good way to solve it. So.
Yeah, and it's not as simple as just putting a net out there and trying to catch it.
No, there's some really good ideas out there, but someone will come along and okay, there's a problem. Well, here's some creative solutions to it.
Absolutely, absolutely. Well, thank you for taking the time and speaking with me. And man, you bring so much energy to. I feel like a kid again just talking about this. I could talk to you about this all day, but we do have to get you to this talk. But thank you for taking the time.
Yeah, no, thanks for having me. It's always fun talking about it.
It's been great. And hopefully we can have you out again. Maybe we'll have another part to this.
Oh, that'd be great. Yeah, and good luck with everything you're doing here. I know you said you're radiation safety officer.
Oh,
and you're doing a lot of other good work. And I think that's great what you guys are thinking. About,
thank you.
Moving forward with reactors and nuclear engineering and things like that. So really
if we get a reactor, we'll definitely have to have you out here again.
Oh, I'd love to. Yeah, that'd be a lot of fun. So
yeah, absolutely. Well, thank you, and thank you for listening, and we'll see you on the next one.